Here.
Laugh. I was about to say, you started laughing pretty weird.
I may laugh at that. Right now, I just like behavior.
Oh my God, I don't know what that means. Yeah, you're over here. Dylan, you want some ink?
Yeah, all over my hands.
No, you don't need to be like, yeah, I know, that's really cool. Hey, it's Friday?
So weird, like, does anybody else do something like this? Or just like, can't do super
Yeah. Oh, it's Friday? It's Friday the 19th. What?
You think? Thank you.
This song's my jam.
These are actually my favorite episodes.
What's chemistry?
Like, it's kind of what needs to happen.
Yeah.
I kind of was planning, that's why I wasn't paying attention.
You could probably
Hello.
Mr. Gussie. What people are on them?
Thank you.
They play this song and X. Wait, so like just if you eat it or if it's like around the class?
Oh my God, I'm fine.
Okay.
I'm tough.
I know you heard this on Monday, but you can't get enough. Make sure you guys have a note sheet. Some of you need a schedule.
That's really interesting taste. It's so plain. Yeah.
Oh, okay. So good morning, everyone. Should have a note sheet. We're going to talk about electrons today. There are certain times in a year when it is imperative that you grasp a concept because it will stay with us and be used. I'm literally talking about how important this is, and I'm having to stop. It'll be used over and over again and be sequenced and intertwined in everything. And I know I'm the teacher, but this isn't that hard. And it has nothing to do with math. It's just seeing the patterns, okay? So today, we're going to do 3 examples of how we do some, basically what's called electron configurations. We're going to place electrons where they quote-unquote live. And it's the same idea every time. And you're going to be hopefully strong at it even by the end. A couple things. One, there is an extra credit opportunity for you. If you are not aware of this, it's also on your schedule. By the ending of Friday, okay, you can submit, and it's submitting, do not hand it in. I will not grade any of them that are in my tour, in my baskets, if they are handed in to me on paper. You submit it on Canvas. The difference between AM and FM radio. So we talked about electromagnetic spectrum on Monday and different kinds of waves and energy and radiation, and there's UV and gamma and all that stuff. Well, there's radio waves as well. And what is the difference? So suggestion, maybe talk about what FM's all about, what AM's all about, and then talk about the similarities and differences. About 3/4 to a page, submit it, make sure the links are where you got the information from, and don't write my brain, because I have a feeling that you didn't come up with all that on your own. And then you submit it on to the assignment that it says AM, FM, extra credit report. Okay, so just like to say this again to those that haven't heard this before about the fact that if you are coming at the ending of a semester and you're like, hey, I'm really close to this grade, what can I do? This is actually one of those things that we look at right away. Well, did you do this? Because if you didn't do this, then what's the point of looking for other things, or if we can even raise your grade? I mean, there's a whole semester. The reason why you have your grade is what you did for an entire semester. So can I hand an extra credit? Well, yes, you could have. You could have this Friday, October 19th. Did you? Well, I didn't know I needed it then. That's unfortunately a decision that you made. So I don't want to make this a negative. Let's have this a positive. Out of 200 kids, usually about 29 people do it. And it's just a mind blow to me because this isn't that hard. It's about 15 minutes sitting down and doing it. I have a little bit of an announcement for you. That your energy or wave sheets, if you have them due today, they can be due by tomorrow. So for some of you, that might relieve some stress. If you already have it in, that's absolutely fantastic.
So like if we got like the one that's due Thursday, do we have to hand in the other one too?
No, you hand in one, whatever one you got.
Okay.
I went to that. I already said that. You have one homework sheet to do.
No.
It is due Thursday.
Or 3.
How's it 3?
Just the
Because some
one we
people
got.
got 3 sheets.
Just do Thursday.
But only one of them is due. One with a note sheet, one with a schedule. We're good. All right, so what we learned on Monday was, this isn't a great image. Is it all done?
They were in quick spots.
So what we're going to be doing on Friday is we have this really cool lab called the Flame Test Lab. And we're putting stuff in fire. Woo! And when it gets into the flame, that's energy, and it's going to cause, if you can look at this image, this isn't on your notes yet, just look. Oh, it's stalled out. That's awesome. Let's go back. Awesome. Well, there's supposed to be this heat right here, and then this jumped up. Right? It was working. When it jumps, it absorbs energy. When it falls back down, energy is released, and the image would have shown a little wavelength. And maybe we see it as green. Maybe it's an X-ray. Maybe it has that much energy in it, and it's more dangerous for us. But the idea is when something falls, it releases energy. So this is kind of what we were talking about on Mondays. When electrons absorb energy, they jump, and this is why we're talking about this stuff, because it's all about electrons, to higher levels. It's like climbing up a ladder. Now you have this energy. It's called potential energy. We're doing physics here. And then when we fall, it releases this thing called a photon. So if you've been confused, like what is a photon? It's basically this energy unit. It doesn't have mass, but it has a certain amount of energy. So it has a certain wave. Okay, so it could be ultraviolet. It could be infrared. It could be green. It could be a radio wave. Okay, so that's kind of where we're going with that. So stay with me. I'll let you know when we get to the notes. So we learned this last time when we talked about atoms. And if I asked you to draw an atom, a lot of you might be like, yeah, that's what I think it looks like. Unfortunately, this is Bohr's model, and the locations are just too specific. It's like a train track. It's like we're saying it's right on this ring, and it's circling around, and it never ever deviates. Yet we can't see it at all, so the fact that we think it's on this ring would be probably kind of crazy to actually say that that's what it is. Even if I just say, hey, let's track your path every day. It's not like you're like, I'm going to class, so I'm right on this line every single day. Like, you're moving around. You're not going on the same path. You might take a different stairway, but you're in a general area. Okay? So what we need to do is get a little more general. So on the top, it says quantum theory on your notes. This is what we believe right now that the atom looks like. Okay? Basically what it is you can just write here, right here. The location of electrons is based on probability. That's what I'd like you to write. Okay? What you are seeing is what we're going to be calling, we're going to be using this a lot, this is called an electron cloud. What is a cloud? A cloud is a fuzzy object, right? Like, hey, where were you on the night of October 23rd? Mole day. You were, I don't know, I don't remember. I'm kind of cloudy on the details. Like, you're not quite sure someone would ever say something like that. So there's not like a defined edge. So what we are going to be doing, you have an image to the left that's pointing to two different clouds. What I'd like you to do, like above and below that line, is you can write this comment here. It's like the probability of those clouds, when we see the clouds, it's 90% of the electron's location. If you're like, I don't know where I'm writing, there's something in the upper left. So there's arrows pointing to two different clouds. Right on that middle line there, what I'd like you to do is write 90% of electron's location. So when you see a cloud, we're basically saying, yeah, we have a pretty good idea it's around this area. Heck, if you've ever lost your phone, or you've used the, Find My iPhone, it's like, it's not usually really exact, it's kind of a general area. It's somewhere in this vicinity. Sometimes it's really crazy and specific, a lot of times it's not. So, we'll come back to this, and we'll talk about some shapes and things like that. So there's many people who contributed, but one of them was Heisenberg, okay? And not that Heisenberg, it was this Heisenberg. But it's impossible to know. So there's the Heisenberg uncertainty principle. We'll come back to the middle. It's right in the middle of your sheet. Heisenberg uncertainty principle. It's impossible to know precisely both the velocity and the position of a particle. Like if I want to find where something is, I have to locate it. Well, if I've located it, I really don't know how fast it's probably going because I've isolated where it is. And if I want to know how fast it's going, I really never quite know where it is. And that's the limitations that I guess we're putting on ourselves. So it's right in the middle. If you're like, I'm not writing right now. This is awesome. You should have been. It's impossible to know, even if you just say you can't know the velocity and the position at the same time. That's enough for me. You don't know the velocity and the position. You don't know how fast something's going and exactly where it is. So we are limited. And that's okay. We are limited on knowing exactly where they are. But we are going to do the best we can in talking about these areas. They're called electron clouds. And they're general bigger areas instead of these like tracks. Okay? So that's kind of where we're going to be at today. I have a bunch of images on the top that you do not have to have memorized, but we have to name some of them as we go. Okay, so I'm assuming if you haven't finished writing, basically, again, it's can't know both velocity and position at the same time. Okay, so let's do an experiment once. What if we tracked where I was in an hour or a day's time? Maybe every 10 minutes. You have a map of school, maybe you're all hidden and you got little things in your wrist and your ear like eagles on the move. And then every 10 minutes you have a map and you dot where I am, okay? So what if I had a low energy day? I was just low, I didn't get my sun drop yet, Maybe stayed up until, 1:15 on the top of the 13th and said it was still tied, so I went to bed and then the game finished about 10 minutes later. As an example, so low energy. Maybe I'm in my room and then I'm in my room. I'm in my room, and I'm in my room. I'm not moving a lot. I'm still in my room. Wow, I went to the back of my room. I'm in the hallway, maybe. Let's see. Oh, I went to go see Mr. Anderson. And I went to go get some food. And I'm back in my room. And what you see is it's making a very simple pattern, right? Not a lot of movement. Okay? Well, that is what we call an S orbital. There's 4 letters you're going to have to know. So first, you'll see that on the upper left. I'm going to help you out with a couple things. That's just on the upper left. It's already labeled for you. Okay? You can box it or underline it if you like. I just want to let you know that it's real simple. We'll get to all of it in a second. This is just about taking in as much as you can right now. Believe me, it'll come together. What if I was higher energy though? So this isn't going, it's kind of staying around the nucleus. Okay, so again, we've already written this. This is 90% of the time I'm there. So if at the end of the day you're like, where is he? Well, I'm pretty sure he's probably in that little cloud. All right, what if I was more energetic? Like, I'm ready to go. I'm a little wired, and I'm moving around. Whoa, I'm already at the lunch. And now I'm doing other stuff at lunch. And now I'm in the SRC and somewhere else. Mr. Neubauer's room, maybe. And more lunch, and I'm starting to move. And I'm moving all over. I went to go get something from my car. And I'm on the tennis courts. I'm hitting a little bit. And when I'm all said and done, it's a different kind of a pattern, but it's a little more complicated. Okay, but that's maybe the pattern that I'm taking for the day. So instead of a circle, I'm taking kind of this lobe area. Okay? Well, this is what we call, and I just want you to physically see it in the upper right of the left. It's called a p orbital. These are the only 2 shapes you're required to recognize. There are more. You'll see all these other pictures. But as I get more complicated, basically, instead of having, oh shoot, I can't go back. Instead of 1 lobe, like 1 circle, I have 2. So I'm going to gain lobes. I'm going to gain areas that I could be because I'm just more energetic. But it's still, I'm going to be here, I'm going to be here. Okay? Well, what these are called, don't look at all these. Or you don't have to write this down yet. These are going to be called orbitals. And what we are responsible for is talking about all the chances of where the electrons live. So I brought some balloons. And I hope they don't pop. So for example, if I have my dodgeball here, which I'm calling an s orbital, no matter how I spin it, I spin it on my, oh, that was actually decent. It's so light, it's hard to do. If I should spin that though in space, it really doesn't take up any other locations in space. So this is where I would be. But if I have, this is tricky, let me try it. If I have a p orbital, I could have it like this. But then, it's like, why does it have to be pointing upward? What if I took up the space like that? Or like this? Like, if I spin this, it definitely takes up different space. If I spin this, it doesn't move anywhere else in 3 dimensions, right? Like here, if I just do this, it's like, oh, it was here, nothing's here, now something's there. So, what we have to do, if you look at these 3, see the x, y, and z? I could be x. Here, hold this for a second. Again, just trust me, it'll all come together. I'm just trying to give you a visual so when we actually apply it, it's going to make some sense here. I could have a different plane. That, please. We're going to see it. So I could be, and it's all perspective, but I could be an x. Over there. I could be a y, like that. Now I'm taking up more space, but why couldn't it be out here? So, it's all part of the show, people. Or I could be a z. So I could take all the different planes. If I let this go, I don't think it's going to stay together. And I have to take it into account all that. So that's why you're seeing 3 different p orbitals that we have. So this is a simple shape. Lower energy. These are more complex shapes. So you have some images on the top. And this is what you're going to need to know. Yeah, some of it's stayed. Okay, these are orbitals. So you have all these pictures right now. So on the top, the first one, you'll see a circle, right? A sphere. Write an S where it says orbital. And then it should have a parenthesis. There is one of those. You have no idea where I'm writing where the sphere is right now. It says S orbital, and then I put a 1. Okay, there's one kind. Notice the P's. I could have it X, I could have it Y, or I could have it Z. All you need to understand from this is the fact that there are more of them is all the possibilities that the electrons could be in. So it's like, well, I could be here, but why couldn't I be like this? Or why couldn't I be like this? That's all. So we have to take that into account. So there's the p orbitals, and there's 3 of those. And we are writing it next to the word orbital and then in the parentheses. So notice, by the way, these numbers aren't that hard. How many are the next one? There are 5 and then 7. Wow, we can count by 2s in odd fashion. So these are D's. Notice they start getting complicated. What happened to the lobes though? I have 1, I have 2. Notice, how many do I have here? 4, and then here, I don't know if you can see it. It's hard to, oh, these aren't actually good images. There should be 8. They're 3-dimensional. You can't see them all. But they're doubling. You don't even need to know that. You need to know these 2. But you need to know all the letters. So this is a D, and then the last one are F's. And there's 7. Now they even get crazier, and we'll show you a link later, not today, on this website. It's called the Orbitron. It sounds like a transformer or something. But these are the 4 letters that you need to know. Okay? Again, if you're like, I don't know what he did with those balloons, I have no idea. It's fine. I'll still get you there. Anyway, but the more that we can have some background, the better it'll be for us. So these are where electrons are going to live. And our job is to basically give the address. Because if we know where they are, we can start talking about why something reacts or something doesn't react. That's why we're learning this stuff. I can literally say that's going to react because it has that 1 electron there. Or it's not going to react because it has an electron somewhere else. Okay, so we can look at this and go, there's nothing right yet. This isn't, every electron fills in from the bottom. So just like you're going to probably do the easiest thing first. If you have a big task in front of you, many of us are probably going to do the hardest thing first. We're going to probably do the easiest thing first. Not necessarily. But there's this order, and it's hard. 1s, 2s, 2p, 3s, 3p, 4. Oh my God, it changes. So I don't want to learn about that. So what I'm going to do is I'm going to cheat. So in the bottom left, middle, there is a cheat pyramid. Now, I don't like to cheat often, but we're going to cheat today. So this thing, there's an actual order. So I need you to take your time writing this. What I'd like us to do right now is you need to fill this in column and row exactly like how I have this. So here's a suggestion. Do this with me first. On the left of your inside the box, give yourself a little space. Move, don't go right to the edge. Go 1S and make 7 rows. Just go 1S, 2S, 3S, 4S right now in the cheat pyramid box. This will be everything. If you can write the cheat pyramid, there is no memorization of any of this stuff that I'm going to teach you today. Then follow suit what's happening. You go to 2P to 7P, 3D, and then a 4F. Write those all out, please. What this is going to do is give us an order of when electrons fill their clouds. Like they gain a little more energy, they move to the next one. They gain a little more energy, they move to the next one. Or there's no more space. Like that cloud is full. Oh, that shelf is full, I got to put it on a higher shelf. So it should be lined up. I always love watching everybody. Some of you you squeeze it in. There was nothing else to put in there, so if you're waiting for extra space, that was the box. Now, the most important part of it all, well, there's 2 important parts. It's lined up, and then these arrows. You need to make arrows going from the upper right through the lower left, but please, if you know you did it right, is like, if your arrow, you might even want to do this one first, it goes through 3D, 4P, 5S. Everything goes at that angle. Okay? Just draw the arrows. They're all at the same angle. We're going to be using this all day. If you're still sitting there going, I don't get it. I wouldn't either. I wouldn't have any idea what I'm talking about yet. Trust that it's going to come together. Trust me. I'll get you there. So, your cheat pyramid needs to look exactly like this. It's not like, well, my arrows kind of look like that, but I took a couple liberties and moved some around because I thought it looked better. Got to look that way. Can anybody, okay, so we're going to talk about each of these, but I want to point out one thing right away. First off, it's a pyramid because it's at an angle. You'd have to turn your head. But notice each, I'm giving something away already. These numbers are called energy levels. What happens on each energy level, I gain 1 more, right? So if you're ever like, I don't know how to start. It honestly doesn't matter, guys, if you don't know where to end. You're like, oh, wait, do I have to know what ends there? No, you could actually go down to 7 for each. You just have to make sure that you don't do a 2 or a 1P or a 3D. You gain 1 each time. So a little insight for the future here. If you do that and you don't mess this up, it's really hard to actually mess up what we're going to do. So we're going to have a cheat pyramid. Okay, so we're going to take that cheat pyramid. Oh, let's do this. Underneath, you might want to put in parentheses, another reminder. So how many S's did we have on the top of our sheet? Then we have 1 S. Mm-hmm. So put a 1 underneath that column. How many P's did we have? How many P's? 3. And then 5, right? And then 7. I'd write that underneath. Maybe in parentheses, because it's not actually part of the pyramid. If you have all that, you're going to be able to apply this to every single thing that we do with the electrons. Okay? So, let's go. I'm going to have this up on every single problem here. So let's talk about boron. Okay? Boron is number 5. If you don't have a charge, that means we learned this in the beginning of the year. Protons and electrons equal. So I have a little spot where there's a line and then E. So if it's number 5, we also have 5 electrons. So make that nice and bold. You need to know it is the number that we are going to use for the rest of each example. So when you know how many electrons you have, it's important. Okay, I'm going to teach you by doing it. I could give you all these rules, a litany list of everything, and you'd be like, I don't know how to apply this. So just stay with me. It takes 3 examples. It's a scientific fact. Okay, you will know it after the 3rd example that we do it. And you'll be like, oh, got it. I didn't know it until that last second. Okay, so check this out. I see that the arrow starts here. The cheat pyramid goes from here. When I get to the end of the arrow, I go to the next arrow. And then I go to the next arrow and the next arrow. Okay? We're going to label some things, so don't take up too much space. We're going to do this under the orbital diagram. So what I'm going to do, put this down just above that line. So if you're wondering, just above this line, right below orbital diagram, draw 1 line and write a 1S underneath it. Make the line not too big, not too small. But put it down on the bottom. We're moving up. I'm putting stuff up here. Okay? So I have 5 electrons to place. Okay? Why do I have one line? Because S's are 1. There's one kind of an S. Okay? So what we do hash little flags. People sometimes do arrows. Let me show you. I did this on the board. Sorry, I hope you guys can see this. Sometimes people like do an arrow. I like to just do flags where I just grab it and go up, or it's going to go down. And you have to have one pointing up and pointing down. I'll talk about it at the ending of this problem. So I like doing that. It goes faster than an arrow. So you can just grab it and go up, down. Okay, so from what I have told you so far is I've placed 2 of my 5 electrons. Okay, that line, I'm letting you know right now, every line can only hold 2. Okay, we could talk about all these laws and rules, but every line holds 2. Think of it as a seat, and on a bus or something like that, and 2 people on a seat. So now where do I go? I'm done with that line. So now I'm going to go to the 2s. Okay, S's have 1 line. So these are energy levels. We're going to label this. So I draw it above. I have 3 more electrons to place. How many can I place on that one, do you think?
2.
2. So I go up and down. And take in what you can. So how many electrons do I have left? 1. What am I going to draw next? Even if you don't know how we're going to draw it, what do I draw next on my cheat pyramid?
2p.
A 2p, okay. Now notice, look at the cheat pyramid. How it's on the side? These are the same energy levels. So I'm going to do it right here. How many lines do you think a p has?
Yeah, good. 3.
3. So what I'm going to do, it's very important, draw 3 lines to the right. This is not an option. It should look like I'm doing this. We want to have some structure. Actually, if you don't realize this, it looks like the cheat pyramid just upside down. And then make a little bracket. You need to say like all of these are 2p. But how many electrons do I have left? I have 5 to place. I placed 2 here, 2 here. I only have 1 left. So that's where I'm going to place it. Now, I think this is where we start learning what the heck is happening. I'm going to label everything on this. And I'm only going to do it 1 time, so the other ones we don't have to label. So if you run out of room, you could label that in your next example. Okay? This is just, we're increasing energy, but the numbers are energy levels. You can just write E level if you want. So every number, the big numbers are my energy levels. We're using our examples to learn all the ins and outs. Did you get a... Are they still back up there? Do you guys have all the... Here. You get mine. All letters are called sub-levels. So it's like you go to a big store and it's like, well, 2nd floor, but then on the 2nd floor maybe there's different things going on there. Okay? The line itself is called an orbital. So an S has 1 orbital. A P has 3 orbitals. What is nice about this, you guys, is that it doesn't change from one example to the next. So the more familiar we get with some terms, all we do is apply it to every other thing that we will run into. If you want, you can say that those are electrons. It might help you. And then finally, 2 other things. They theorize that electrons have kind of think of like a north and a south pole. So if it's spinning one way, if it's spinning the exact... Wait, I'm not doing this. If it's spinning the exact same way, it's going to even repel each other more. So what we need is an up and a down spin. That's what that's showing. If one's pointing up, the other's pointing down to reduce the repulsion. Because electrons are already negative. They're not going to really want to sit next to each other all that much. And, okay, that's it. So, this is called an orbital diagram. Diagrams, when I hear the word diagram, I think of drawing things. Electron configurations you're going to love. They are like a shortened address. So like this is like a Google map, and then this is actually just the address written out. So, what do you see? I see 1s. How many electrons are in that 1s? How many are sitting? 2. Check this out. Underneath electron configuration, I have 1s2. And it's not 1s squared. Hear what I'm saying. It's 1s2. Then what do I have? I have 2s2. And if you're like, wait, you didn't fill these lines. I didn't have enough electrons to fill it. If I don't have them, I don't have them.
2p1.
And then it's 2p1. 2 plus 2 plus 1 is 5. It's the shortcut. Eventually, you guys, you may not even need to draw this. You're going to get so good at doing this that you can just write this out right away and be like, oh, I know there's an electron in that p orbital, and it will mean something to you. Okay? Okay. We got to compare and contrast. So hopefully you have that all written down for the first one. We're going to go down to the lower left, and we're going to do this again. Just going to do it 3 times. I mean, we could choke you with huge electrons problems and make it much more difficult, but it's not needed. So let's look at phosphorus. How many electrons does phosphorus have? 15. Yes. So write 15. If you're like, well, how did you get that? It's the same as the atomic number for now, because there's no charge. Okay. So what I'm going to do this time, because it's bigger, I want you to realize, think about this. If you had to start on the bottom each time, what if you ran out of space? Or you went way down here, and you only came up this high, and you're like, I have all this space. So what I'm going to do this time is I'm just going to go downward, and it's actually going to mirror my sheet pyramid exactly. So I'm going to do 1s. So put this up on top this time. Upper left on your sheet. Sorry if you already wrote the 1s, erase it. Upper left on the phosphorus. Okay? And then I do 1s, and there's 2 of them. Now, notice the columns are the same. It mirrors this. So the 2s would go underneath the column, new row. So basically, I just revealed what we did last problem, right? Like, I already now know that's how that works. So that's boron right now. Well, it's upside down. This actually is better for saving space. Okay, I need 15. So it's 1, 2, 3, 4, 5. Now, I know some of you are moving ahead of me, that's fine, but check out how I'm filling this in, and I'll talk about it eventually at the ending of this. It's 5, 6, 7. If you can get in a habit, it actually goes faster too if you go up, 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 and then back. Don't go up, down, up, down, up, down. And you're like, well, that's your choice. I want to do it this way. There's a reason. It's because, and we're going to label this in a minute, is that it's kind of like when you're little, you probably all want to sit next to each other on the bus. But now that you're bigger, like a lot of people, like, I got this spot, and you fill in the bus first, everybody by themselves. But then eventually, it's all full, and now it's like, I have to sit next to somebody. I'm going to pair up with you. So it's kind of, electrons are all negative. It's more stable that they're all apart first. It's more balanced. Then they come back in because they have to. So down, down, down. That's 10. I need 15. Okay? So now where do I go next? Sheet pyramid. What's the next thing I draw? 3s. Where do you think that goes? Below the 2s. Yeah. And then I'm going to go, what am I at? 10, 11, 12? If you're like, whoa, how did you know that? This is important to see. Sheet pyramid, you got to understand. It goes 1s, 2s, 2p, 3s. Now what? 3p. I come back up, 3p. I'm going to draw it right here. All the p's are lined up. I have 3 left. What's it going to look like? Up, 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 or up, down, up?
Up, up.
Up, up, up. Not that. And if you can, in the side or somewhere without taking away your electron configurations, this might be the last definition I give you today. Like, pure definition. This is called Hund's rule. You will need to know this rule. Did I skip a rule? Oh, I skipped how. Okay. We'll come back. Atoms in the most stable with max number of unpaired. You can just even say max number of unpaired electrons. Whenever I write electrons, I just put an E negative. We write the word electron a lot in chem. Just put an E negative. I skipped something, guys. When you're done writing that, if you want to just take a moment, can you find a very funny sounding name? An Aufbau principle. It's right in the middle. Very German. Very German. I'm paraphrasing. I don't think I have it written here. It's basically electrons fill lowest energy first. Okay? So that, like, you don't say, hey, first electron, I'm going to go 3s. Aufbau principle, electrons fill lowest energy first. Lowest energy levels first. I'm paraphrasing. But that's in the middle of your sheet. Aufbau principle. Electrons fill lowest energy levels first. And that's what the sheet pyramid is, guys. The sheet pyramid is the Aufbau principle. That's the order. All right. I bet you can do this without me. The electron configuration. I bet you can do this already. And I haven't even taught more than one example. You say the letter, the energy level, the sublevel, and then the number of electrons. So I hope it's not a surprise. I'd say here, you can just say it with me as I'm saying it. I'm saying 1s2, 2s2, what's next? 2p6, 3s2, 3p3, right? 3. Well, does it matter if I mess up the order? Actually, technically not. I like to just read across. What are all those little superscript numbers equal? If I add these all up, these little ones, it equals 15. All right, one more wrinkle to this. And if you're going ahead of me, I'd stop. All right, stay with me. There's a reason why I'm doing these 3 problems specifically. Okay. Iron. How many electrons? 26. Please write it. Okay. I'm going to jump to where we just left off. This is the beauty of this problem. Watch this. This is where I just, and you're like, slow down. I will. But is that not 15? It's just as true on the last problem as it is now. So you need to understand that there's comfort in the fact that, well, yeah, I know that that's 15. I just did that problem. This is 15. So I'm going to give you a moment. Structure this, please, on iron. Get to here. But please don't go ahead. Like, it's exactly the same every single time. So when we have students eventually, like, and it's troubling in 2 weeks from now, like, I don't get this, and then they can't start it. It's like, you clearly, truly haven't started this at all, because this is the same problem every single time. You sit down with one of us, it takes less than 10 minutes to start actually seeing this if it's not clicking the first time, or some of this, as always, kind of, we digress a little after we hear a lecture. You understand it right away, right? And then like 2 days later, you're like, oh gosh, I thought I knew this better. Because you got to practice. This is where the cheat pyramid is everything. So first off, 15, I hope we agree that I got to fill the rest of that yet, right? So I got to go back through. So we can do that. Down, down, down. And now how many do I have? 18. Word to the wise. If you can memorize, like we urge you guys to memorize oxygen 16 and 14 and 12. If you can memorize, that up to 3p is 18, it's amazing how much faster you can do these problems. And there's a couple reasons why I bring that up. One, usually the problems we're going to give you are a range between 10 and 30. So this is kind of right in the middle. Secondly, what comes after 3p? 4s. Okay, I'm hearing 2 answers. This is what people do, and this is the mistake that lies. This is why I'm doing this problem. You are not reading like this. And if you're like, but we were, it was going like that. Very true. But the next one is not 3D, it's 4s. You don't need to know why, but let me just explain that this simple shape is much less complicated than a ton of lobes. You're like, well, how am I supposed to know that? You don't need to. The cheat pyramid tells you that. The next one is the lowest energy available. So I would draw a 4s underneath. And oh my gosh, it's just like that. So how many go in there? 2, right? So I'm at 19, 20. Now, what do I draw? Now I draw 3D. Now let's think about what we're going to do with that. Where do I draw the 3D?
Next to 3p.
Right here, right? How many lines does a D have? 5. Well, how do you... It's 1, 3, 5, 7. Every time. So this is what it's going to look like. And you're like, I'm out of space. Yeah, that happens to me a lot too. You got to make them really tiny then. If I had to do an F, I would draw 7 lines. When am I going to do Fs? Fs don't happen for a very long time. So you're hardly ever going to run into that. Okay, I had 20. How many do I have left?
6.
What is that going to look like?
Each one has 1, and then the first one has 2.
But you could actually do down, down, down. Usually people do up, up, up. But the beauty of this, you don't have to know beforehand. You're like, I must know exactly what it's going to look like. If you get in a habit of just going up, 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 and then, like, let's say you only had 4. You wouldn't go up, down, you go up, 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 up. Oh, I ran out of them. I'm done. But I have 6, so I go up, 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 and then I go back down once. And I don't have to know that beforehand. Like if you're filling in and go up, down, up, 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 I said too many. You're trying to do more work in your brain than you need to. You just knew you had 6. Oh, I ran out, I come back. So this is the orbital diagram of our last example on the front. I'd like you to do the electron configuration without me. Let me give you a little peace of mind on this. You do not have to follow this. I actually just go straight across. Oh, but the D is going to be given before the S. Doesn't matter. You're saying how many are in there. Electron configuration is a shortcut of where they exist. The orbital diagram, you need to use this to actually know where they go. So if you haven't already done it, you have. That's awesome. Give you 30 seconds. Do the electron configuration. Make sure those numbers are little for the superscripts. Those superscripts should equal the final amount. I never count them up. That's, to me, usually that's a waste of my time. Like, I feel good about this already. So, as you're finishing this up, I'm going to do it right now. It's 1s2, 2s2, 2p6, 3s2, 3p6, 3d6. By the way, I'm not counting these. If it's full, here's another tip for today. If this is full, it's 2. If this is full, it's 6, right? If this was full, it'd be 10. Like if they're full, don't count them. Oh, wait, 1, 2, 3. It's full. They're 6, right? So it's 3d6, and then I write 4s2. And that is the address, in a way, or locations, I should say, not an address, actually. The next thing we do is technically the address. Those are the locations of those electrons. All right. So we're going to practice that. I promise, if you give it a little time, it will start to make sense because it's a repetitive thing. If it's not making sense, you have to come in. All right, flip it over to the back. In my opinion, this stuff's even easier. It's called quantum numbers. So I have a friend, my panda pal. I started doing this and I like all that alliteration. So my panda pal has a panda party and he's going to bring some pineapples and prickly pears. So he's got to find the party. He doesn't know where to go. Pity. So here it is. He shows up. He's standing over here. So don't give it away, but does anybody see where the panda party is? Anybody located?
Yeah.
Okay, if someone's located, don't tell me. But if your panda pal has parked his Porsche over here, what would you want to tell that panda first? What's the first thing? What? Yeah, okay. Then, what first direction? Probably the street, wouldn't you? Okay, so I would say, don't, if you're writing this down, don't please. So you'd say the street. I don't know what's happening. So yeah, hey, there I am. So you probably say the street. Okay, so now he gets on Elm Street. What would you want to tell your panda pal next? What next?
6.
The building, right? So, oops. So you'd say the building. If you still haven't seen this party, then we need to go get some glasses. So now, okay, they get to the 6th building. Then what do you want to tell them probably? What? The floor, and I don't expect you to count it. Oops. So you'd say the floor at 1, if this counts as 1, let's say 2, 3, 4, 5, 6, 7. We'd say the 7th floor. They get up to the 7th floor, and then you tell the panda that it would be
Room 2.
room 2, assuming that it goes from left to right. Right? So there's steps. That's all. So that's what this is all about. So, oh shoot, that shouldn't have all popped up. Okay, that's okay. What we're going to have, you should have 4 big lines. Okay, I'm going to give you a moment, and I just want you to take like 2 minutes. Write this under each of these lines, and then I'll talk about it. This is truly, besides writing some numbers, this is already the ending of our notes. Besides writing a few numbers then, in columns. And it's better just to let you write these, and then I will explain. Panda pal. Maybe it's parallel parking. I saw it on here. Let's say, looking up some phosphorus. I'm like, oh, that doesn't have the same sound. That's horrible. Potassium does that. What you were writing is just like what the panda had to do. You said the street, then you said the building, then you said the floor, then you said the room on that floor. What we need to do is start basic, and then we need to get more specific with each number. When you are done with all that, please assign this 1 electron where I have it, and make it nice and solid and big. Like really, like exaggerate. Exaggerate this 1 electron. Make sure you get it in the right spot, or else it's a disaster for you and when you look at your notes later. And I want you to exaggerate it because we're going to put a couple other electrons on here as well, and that 1 electron is going to apply to these lines on the bottom. So, what we're doing right now is, if I asked you, where is the location of that electron? If I was a panda, I'd show up you, and what would you say? First you'd say the street, right? Then you'd say which building, right? Then you'd say which floor, and then in this case, it could be which room. That electron could be doing that. What's another way an electron could look on that line?
Down.
Could be going down. as well, up or down. So the first one's energy level. Okay, we're going to get specific. So what would I write from on my big line?
4.
It's a 4, right? It's the 4th line. So in a way, I could now like not imagine any of that there. Okay, now this is the problem. These are called quantum numbers, not letters. So this is the one thing that students mess up on, is that you have to realize that we can't write F. So these are the numbers that are assigned. So as long as you can remember this is 0, 1, 2, 3, that's all. This is not a 1. That's where people mess this up. This is not 1, 2, 3, 4. It's 0, 1, 2, 3. So an F is a 3, so I write a 3. So now I'm on this spot. Okay, now, how do I say that I'm on that orbital? That's what this is, the orbital. Which line am I on? You can't be like, oh, it's the second from the right, or it's 2 from the middle. So this is how we do this, and I suggest writing these all down. What we do is if you say the middle is 0, just write on the top lines with me here, then what I say is to the right is +1, to the left is -1. Let me show you a different example. If you say that one is 0, yeah, +1, -1, so what do you think that one's going to be? It's going to be +2 and -2. So we're always talking about the same language. S's are the easiest. It's not a 1. If there's only 1 there, it's the middle, so that's a 0. So, where is this one? -2. And I wrote this out. It's your call if you want to, but I wanted you to physically see it. So, it's a -2. It's off the center to the left 2 times. Okay? So the key to that one, you make the middle 0. I find students, when they practice this, they can pump these out pretty quickly once they understand what the numbers are. Then, the last one, it's a unique number. You just got to know this. If it's pointing up, it's a +1/2. If it's pointing down, you write negative. You write a plus or a minus. So in this case, it's pointing up. So bless you, it's a +1/2. So last challenge of the day, besides doing a homework problem with you, is what I'd like you to do. Don't make these quite as big, because I want you to know that that one is this. Just draw an arrow somewhere in an open space and write a number, comma, number, comma, number, comma. No, wait. 4 numbers. Don't put lines under them though, just put the numbers. I want you to try to assign quantum numbers to these 3 different electrons. Then we're going to do them together. So if you can already even get close or get these right, you should have a lot of confidence with that. So as you're doing that, I'm going to hand out a homework sheet that's pretty short. So work on those as I'm handing this out.
We're doing this for those. Pretty sure that's what we want to do.
If you're like, I don't know. Look at the energy level first, then assign what letter it is with a number, then assign where it is in that sublevel, and then is it pointing up or down, +1/2 or -1/2. So you'll be able to do all 3. Again, I would just draw an arrow. That's what I did. I just have them in open spaces. So if you're like, I don't know what I'm doing. Let's do the first one. Anybody want to say, what do you think this first one was? No, the whole thing though. It's 3, 1, 0, +1/2. Yep. 3rd energy level, it's in a p orbital. It's in the middle of that orbital, and it's pointing up. So if you're like, oh, okay, try to do the other 2 without me if you haven't yet. I'm going to do the 3D one next, and then I'm going to do the 2S. And we're doing great on time. All right. As we finish, anybody want to, what is this one? This is a 3, 2, +1, -1/2, right? 3rd level, it's a d orbital, it's 1 off the center to the right, and it's pointing down. The S's are the weirdest ones. Because it's a 2, what does an S get? S gets a 0. Because it's on an S, it's also a 0. So every S is a double O. It's a James Bond, bad joke. You always have double O's though, and then it's pointing up. So every S always has 2 O's in the middle, no matter what. It's the only one that can actually be said that it's a lock, and it's always going to be that way. Okay, so if you look at your worksheet, we have one more thing to talk about besides this. Guys, what I just want to point out is the first 3 problems I gave you structured orbital diagrams. I'm not saying all that is going to be filled in. What I'm just trying to urge you on is giving you a good head start and showing you where things might be located. They're not all going to be used. After that, you have to create your own. Okay, so please understand, you're not just filling every single line up, down, and it's done. Yeah, you have to figure that out. So you write the electrons first, and then, and I wrote that already. First 3 problems are pre-made orbital diagrams for you to fill in. Starting at number 4, you will have to draw them in yourself. Okay? All right. Final thing to talk about. Tuesday is mole day. It's like in math, there's Pi Day and everything else on 3/14. Well, on October 23rd, that's 10 to the 23rd, is mole day from, we only get a half a day, from 6:02 a.m. to 6:02 p.m. It's kind of get gypped a little bit. But we have the Olympics happening on Monday. And there's a couple little things that you have to do, okay? So on the website, I want to show you, and this should be fun. There's a link right here. You click it, and I gotta switch this. This should say create. This should be color. Okay. I don't have the examples with me right now. That's okay. What you do, it's on your assignment sheet. If you're not artistically strong, then it's not necessary. I've seen people do amazing work with ones with their projects, and they weren't the strongest artistically, but they had a creative idea. So this is just an idea. You don't have to do this. People have created other things, but you need to create a mole. Now, this is the simple way of doing it. You print out this sheet, you cut it out. I suggest drawing on it first. You can give it some body, putting like some puffs plus or something like that in there. But there's some examples on the bottom, like Beyonce moles, Mokel Phelps instead of Michael Phelps, Mokel Jackson, Molbama, Napoleon Dynamole, Marilyn Monroe. You can have all sorts of funny ones. There's always a clay mole fuse. And what you do is you make a mole. And again, I've had it not made out of paper. I've had clay. I've had wood. I've had all sorts of stuff. And you can enter that to try to compete against others. If you don't want to put a ton of time in, then just do the bare minimum and make something. But you got to have a name. And you can put your name on that. We'll talk more about it the rest of this week. But you got to create a mole. Then there will be 4 categories you can place this in. It can either just be best overall coloring, or it can be most Wisconsin. Like there's this one, the Molar Bear. This is one of my favorite ones ever that I saw. These are cartoons, and they made these guys with paint cans, and then this guy had a Viking helmet on, and then they tagged his igloo with Packer graffiti all over it. And so that was like most Wisconsin, and the Molar Bear was all that. These are all play on words with moles. This year's theme is Moley, from the National Mole Day Society, is Moley Potter. So that's this one. Last year's theme was the Molevengers. This one's pretty cool. So it's all different superheroes that look like moles. If I can, okay, it's not gonna. And Molevengers, Earth's mightiest unit. And you can color that in. And my favorite though is guacamole. And it says ingredients for 1 bowl of guacamole, 6.02 times 10^23 avogadros instead of avocados. So you get to choose, and you need to make these, and that's for Monday. And then you're going to come in and you're going to compete.
Wait, do you have to do both or just one?
You got to do both. Okay, and what we're going to do, I know it says on the sheet maybe times 2. I'm going to require you to do 1 of each. We used to make people color 2. If you like to color 1 more, you definitely can enter it in another one and help your team and help your points. If you're going in, there's all sorts of funny ones in here though.
It's going to be a great try.
Wait, so you have the color mole and create a mole?
Yep. We usually make you do 2. You only have to do 1. This is a James Bond one. It's already done for you, and you can add stuff. Oh, that one's not so cool.
Moloranus Rex.
Where are you?
Yeah.
Yeah, this one's cool. Molosaurus Rex. Again, you can add things on there, make it more Wisconsin. Lawn molar's funny. So anyway, that's going to be online. We'll remind you a little bit on that as well. That should be fun though. Some people really get into it. You want? I know I have the winners and some of the greatest ones I've ever seen on my Mount Rushmore up on top of my cabinets if you ever want to see some of them. Actually, Miss Elder Feezer's sister has the best one I ever had. Hers is on top. It's Miss Elder Feezer's sister.
So if we don't do this, we get points on.
Yes, these are points. I'm creating one and coloring one. Yes, there are actual points. So your stuff's due tomorrow for your energy.
Hi, Cody. Oh, you pass it? What'd you get wrong?
I got 10 wrong.
What's it for? What do you mean?